Okay, hello, Hacksters. We are coming up on Halloween here, as I'm sure you know, uh, and we're just about to launch a bunch of cool content around that, in fact. But I thought I'd get started with this. Well, actually, it's not getting started. Last week we had a video about spooky PCBs, so you should check that one out and subscribe to see more of our cool Halloween coverage. Okay, anyway, Halloween and electronics they go hand in hand. And I've been planning this robot for about a year now, which seems perfect for the season. It's a furry black bot that was originally designed to be based around a black cat. Um, but now I got very excited about raccoons, and you can see exactly why in this video that I shared of a couple of little baby raccoons that I ran into out in the wild in my neighborhood. They are so cute, and I love their little mischievous grabby hands and stuff. So I've designed some bits for a raccoon bot already, and I want to test some of them out and actually complete this robot this year because I started doing it last year with the goal of having a warm, fuzzy therapy robot to help me get through the winter months because I can't have pets where I live. And I want to actually finish that out this year because it's about to be winter again. It's spooky season. There's all kinds of cool stuff going on. I haven't yet gotten my hands on some paper clips, but let's test out these legs first because I showed you those already. So these are little raccoon paws that I designed in Onshape, which is a browser-based CAD tool. Just jumping in here. They're printed with 3D Tough ink, which is made by M3D company who make 3D printers. And it's designed for use with their printers, but it works with other ones as well. We've got this paw that sort of curls up, and I wanted to go with a design that starts with larger pieces and then goes to smaller pieces because that way it will curl smaller and smaller as it curls up. So, you know, the forearm has its kind of whole shape, and then the start of the paw, and then the little fingies. But my plan has been to connect this fishing line through here and have a servo tug on it. I want to use a paperclip to go through there, which makes the most sense to me. But since I don't have that on hand, we're going to use safety pins. And today we're going to test a few different things. It's a live hack, as I mentioned, so it may not be the most organized. But yeah, we're going to be testing out these little flexi legs that I made. We're going to be trying to assemble a Companion Core board, which is this skeletal board I designed a couple of years ago for use with companion bots, based on my prior bot, Fenrir, who's a little fennec fox bot. This one is an adaptation of the design that I created then with just some proto board, and it was horrible, like so much soldering. This is going to be so much nicer to use. And basically you connect this breadboard on here and then attach whatever little microcontroller you want on there. I've got a Teensy 4.1 here, but there's also going to be an Arduino Nano 33 BLE Sense in the robot, which is actually one of the boards that this was designed for. It's designed to break out a Teensy 4 or any Teensy version or one of these Arduino Nanos. There's all kinds of other boards that you could connect to it. But basically you're connecting that board on a breadboard to different peripherals, be those servos. It could be my per module that we'll take a look at in a little bit. It could be NeoPixel strips. It could be pretty much anything. And the newer version that I have here actually has spots for transistors as well, which makes it easy to control higher voltage things. And we're going to get to that as well. So not only is there going to be a per module that I've designed that will make it the robot per, but also I've got all these components from LOOMIA, who make pieces for smart e-textiles and things like that, and fashion tech, and even cars and things like that. So everything from fashion to cars to other types of upholstery to paper crafts even. These are little pressure matrices, pressure sensors. They also sent me some individual pressure sensors and some connectors. Let's take a look at that more in depth for a minute. We're going to get back to the hacking in a second, but first I want to give you a broad overview of what we're going to do. So Roko is the focus, raccoon-esque companion AI. We're using LOOMIA, smart e-textile pieces, super cool. Oh, the LOOMIA electronic layer is a soft, flexible circuit that can enable next-generation products in wearables, automotive, and beyond, costing as little as 5 cents per square inch. So cool! You can find these on Supercon and Adafruit and stuff, but what I want to get at is I've struggled really hard with how to make the face for this robot, and I've gone with felt, as I used for firmware. I've gone with 3D printed pieces, but look at this! Doesn't this look exactly like a little raccoon face? I really want to get this and use it as the face for my robot, and then it would be totally a raccoon. Oh, look at it! I think it's a couple of buttons, and they light up. So it's like the single backlit button, but there's 2 of them. Ah! So, yeah, I think that would be perfect. I've printed parts using this Creality printer that I have, and I'm using this 3D Tough ink from M3D. I've also linked below the Companion Core PCB that I'm going to be using today. As I mentioned before, I just showed you that. And this is a breakout for Teensy's, Arduino Nanos, and similar boards. Here's the per module. I've actually given away all my copies of this. It's a flexible PCB that you can mount up to 4 haptic motors on, and believe me, it really gets going. I've done a demonstration of it before. I think I soldered it together on this stream, actually, and you can see the very explosive demo at the end. And then also I've got an unboxing for the LOOMIA soft circuits components that I've done before. We're also going to take a look at Edge Impulse. So I've actually written, I haven't written the code yet, but I created a demo that basically allows me to take this ocarina, which has really pure tones. Anyway, it's got really pure tones, and I thought that it would be perfect for doing Edge Impulse style AI with. So basically I'll be able to play tunes on this ocarina and have the robot respond to them. This, I may adapt it later if I learn to whistle better. Just I want to have a way to interface with the robot without pushing buttons and stuff. And I've had a little bit of trouble training machine learning neural nets on other types of data, just because I think that I need to learn a little bit better about how to optimize and enter my data. But the ocarina seems to work really well, so I'll show you. Is it here? Training output. Yeah, look at this. That is unheard of. Oh, I'm not showing you. There we go. Look at this. That's ludicrous. 100% across the board. And I think it's because this ocarina is producing extremely clear, like sine wave style tones. So I thought that would be a cool one to integrate into the robot. You can also find on the tutorial linked below a link to my flexi robot paw, which I'm about to try out for the first time. We'll see how it goes. I'm not going to hook it up to servos today, but you'll just have to stay tuned for that. So now I think we've covered everything that I'm going to talk about. Let's actually dig into doing this stuff. Woo-hoo-hoo-hoo. Yeah, it really does look like a raccoon face, doesn't it? Okay, so we're going to test this robot paw. We're going to try and solder together this Companion Core board and put headers on this Raspberry, not Raspberry Pi. It looks like a Raspberry Pi Pico. Actually, no, this is a Raspberry Pi Pico. I thought this was my Teensy 4.1. Maybe I should put the Pico on it anyway. I think I'll just stick with the Arduino for now. They look very similar, honestly. The Arduino, the Teensy 4.1 and the Raspberry Pi Pico W, because it's got that little antenna on it. I'm not going to force this right now, but fortunately that's not necessary. Okay, and then the third thing we're going to do is I've never actually connected this heater to power before, and I'm going to check out how warm it gets and if I need to stick anything else in the circuit to modulate that, or if I can just sort of PWM it or what. All right, so first I've got this fishing line, just standard fishing line, and I'm going to insert it through this paw, and I'm going to tether it at the end using this safety pin. Later on, that is going to be just a length of paper clip that I stick through there and bend around so that it doesn't show up very much. But for now, we've got this kind of ugly situation here. So I'm going to close that up so I don't hurt myself. close. There we go. And I'm going to tie this off. I have to pull that through a bit more. Go through there. I don't really care about leaving a long end on it. I'm going to cut it off. And maybe melt it together with my soldering iron. We'll see. Did I do that the right way, or did I end up with a granny knot? I think I ended up with a granny knot. Oh well. This is just a test, so it's fine. Okay, here's the big moment. Well, first I'm going to cut off that end because it's bothering me. Let's use the really pointy guy. Okay. Pull it tighter first. There we go. Close enough. Okay, are we ready? Ah, look at that! Little grabby raccoon paw! Ah ha ha ha! Oh, this is so exciting. So basically I'm going to hook up a servo with a little pulley style wheel, like a smaller version of this. This is actually a double one. But like a small version of this type thing, and wrap the cord around it for each paw, and then I'll be able to, whoop, you know? It'll be so good, and it'll be able to grab stuff. I'm still not sure exactly when or what it will be grabbing, but yeah. So exciting. Okay, so again, this is printed with flexible filament and designed so that it will curl up. And then these are obviously mounting holes. You can stick it on either side of something 3D printed or laser cut and stick bolts through. I think they're sized for M3 bolts, but you could do whatever. And then there's a little channel here so that it's sort of held away from the surface. And yeah. Haha, that's so cool. It's flexible enough that it will perform this action. And I'm going to apply fur over the top, but then also it's rigid enough that these have some durability. So that's very exciting. Speaking of durability, I want to show you something about the exterior of the robot. I'll just leave that wrapped around there. Originally, I had planned to use an old rabbit fur that I've had around for years, but I took the robot to a meetup last winter, and in its prototype form, and sort of passed it around and got people's thoughts. And I noticed that people were very like, people don't necessarily know how to pet an animal or an animal fur and like be gentle with it. So I decided that instead of using an actual animal fur that would be kind of delicate, I'm going to use this faux fur scarf that I got also about a year ago, also with the aim of building this robot. So it's very, very cuddly, and there's like a whole bunch of it. And I don't really need to worry about destroying it because, again, it's something that I can just easily get again. We've got some sunlight coming in here. Oh no. We dread the day star. Well, it screws up my lighting for the video. Okay, but yeah, faux fur robot. That's going to be very exciting. And then another part about the structural nature of the robot is we've got this skeleton that I made. Check this out. So this isn't all the way assembled, but I've got this basic idea of a laser cut / 3D printed skeleton. And it's laced together basically with zip ties, which I've found to be very durable and flexible and really good for the whole life of a robot. And then it's separated by little pieces of heat shrink, which is cheap and easy to find, and you can reuse it even if you decide to take it out of your robot. If I decided to make it stay one shape exactly, I could probably shrink this down onto the zip ties so that it would be more stable. But for right now, I'm just prototyping and like seeing what happens if I put different lengths together to create a curve shape. See how these ones are shorter, so the robot curves in that direction. Just playing with things like that. But the skeleton works really well as a base for the robot. And I'm curious whether I'm going to stick with that or choose something different, because now I'm like, it's going to be a lap bot. Do I want to like paper mache a body for it to hold the electronics so that I can use recycled paper. I don't know. It would be very light as well and pretty durable. I'm really a fan of using zip ties and things, and you'll see that I also have some metal ones that are used in various construction capabilities. These hold very well, and they're very flexible and kind of tough to cut, but I'm not sure that I want something so permanent or potentially conductive, you know? And then there's also these massive zip ties that I got at Harbor Freight. Look at how long that is. Whoa, it's like 2 feet long. It's like 2/3 of a meter. Anyway, massive zip ties, very durable, very flexible, probably will be great for the lifetime of the robot. Imagine using this as part of a tail or part of a big long spine that can be like however long. I might put several of them in parallel to make a sort of spine going through a paper mache structure. We'll see. You shall now be known as Alex Grabby Hands, referring to the little grabby raccoon hand. This makes me so happy, you have no idea. Grab! I made it like a year ago, but all of a sudden I'm reminded of how wonderful it is. Okay, second up, this may not be very obviously interesting for the camera, but I'm just going to try really quick soldering this heating pad to a power source, this USB cable, which I'm going to stick in a USB power bank. Not too much amperage, etc. And just see how warm it gets. Now these are not labeled. We've got 2 larger pads and 2 smaller ones. Let's have a look at the documentation. So again, this is a heating piece from LOOMIA, and they have information. Supercon usually has really good information about stuff. Documents, quick start guide. Pull that up. Really nice that they have beginning documentation, using this guide, safety information, etc., etc. Connecting to parts. Here we go. Alligator clips. Very friendly for that. Sticky backing. Yeah, there's sticky backing. This stuff is sewable. All kinds of good stuff. But let's see. Connecting. Headers. Alligator clips. Tell me. Don't be intimidated by trimming the connector. You'll master it quickly. Oh, here we go. Pad guide. Power and ground for heater and LED. Okay, cool. This is really cool. Huh, wow. So my assumption is that since they put them in this order, power is the larger one and ground is the smaller one. So those are the outer ones. Yes. Okay, cool. Here they've got a little USB thingy. Basically the same as what I've got here, only they've connected it to a long flexi bus. They've got, yeah, power and ground. Okay, cool. Most LEL parts can run off a 5-volt power bank. For high current applications such as heating, make sure the power bank can output at least 2 amps. That's good to know. And then they say something about how power banks will often shut off after a set period of time. If you have low current applications, that's definitely true. And there are dummy loads that you can get to make sure that those, or keep alive circuits that you can use to make sure that those don't shut off on you. Now, how many amps will this output? Output 2 amps max. Okay, let's try it. So I'm going to try and solder this onto ground and power. Oh, you know what? Let's do it over here. Let's do it over there. I'm gonna tin these guys. I like to use a method where I make a little cobra shape out of the solder, make sure this is twisted up. And then here we go. Oh, you know what? I might need to strip this a bit more. Can we make it? Probably, but we might get some shorting. Let's make that longer. This might get a little bit messy. I try not to clamp down too hard with these strippers. This is how I usually, after clipping off the end of a USB cable, which is what I use to power a lot of my robots, I'll just go ahead and take these extra little shielding wires, twist them together so they don't go everywhere, cut them off, put them in my little desktop trash can. Do the same with this shielding foil. Oh, that's coming right off. Then I cut the other two wires that we don't need that are for data, just to keep them from shorting anything. Did I get? No, I didn't cut it into either of those. Cool. Dude. Try to cut them at different lengths so that there's no chance of them shorting on each other. And then there we have our end. And you already saw where I had stripped and tinned these guys. So now let's hook these up. Stray piece of wire there. Get out of there. Get out of there. Get out. Okay. Solder you down. And solder you down. Okay. And now I'm just going to hook this up to my power bank and see how warm it gets and in how long. So right now it's, desk temperature. Trying to make sure that I'm not just heating it up with my hand. Oh, tell me about those batteries. This is definitely still on. You can see the little LEDs go. Hard to show, but yeah. So here, if you're just joining, I'm testing this LOOMIA heater, which is an e-textile heating pad that runs off of 5 to 7.2 volts. And it is definitely getting warm. Oh, this is going to be so nice. A large reason that I want to build this robot that this is going to be part of is that I want just like a pet to sit on my lap and keep me warm. I'm such a chilly person in winter and all other times of the year. And so it makes me very happy to have, to just think about having a little furry robot that will keep me warm. Yeah, it's getting comfortably warm. This is going to be wrapped around basically the bottom of the robot and far away from any of the control parts. So in this skeleton that I made and showed you a minute ago, the idea with this version was to have the all the controllers and stuff mounted on the back of this front plate. This is the front of the robot. This was going to stick out and hold a neck servo, but I never quite got that far with the previous iteration. This is where I was going to put a pressure sensor matrix. And then around here would be the heating pad of the robot. And also the purr module to make it purr. But yeah, so this isn't going to interfere with any of those electronics. It's still very comfortable. And if it does get hotter, so it took, maybe a minute to get up to heat, to just being warm. And if it gets hotter than that, it has plenty of range to go up before it becomes uncomfortable. But if it does, then I'll be able to just PWM it, turn it on and off to make sure that it stays a comfortable temperature. Very cool. What programming environment do you use for your companion bots? Okay, so I've sort of settled on a system that I really like. Let's look up firmware, actually. I'm going to show you really quick. Firmware. You can actually see him behind me on the shelf here. Whoops. Doop. My little Fennec Fox companion bot. And then there's Archimedes the owl as well. Both of these use a system that I assumed I would sort of grow out of as I grew more competent with using Raspberry Pis with servos and things like that. And also with combining, making one Arduino run different things at the same time. So like, sensors and such like, and then also motors. But I found that I really like having a separate Arduino brain for the motors. So basically on most of my robots, I have an Arduino or a Teensy, actually, usually a Teensy controlling the motors. And I have code on the Teensy that will respond to serial data input from the other controller, whether that be a Raspberry Pi or something more advanced like this Arduino Nano 33 BLE Sense or the Arduino Nikla Vision. A lot of these boards don't have great support for servos, and the Teensy is really good with servos, and it's nice to not have to worry about timing issues, which are huge with servos as well. So I tend to have like a separate motor controller that's a Teensy, um, being controlled, like getting input over serial from, in this case, the Raspberry Pi 3 Model B, or in the case of Archimedes and Arduino Uno, I think it was. Well, there's different versions of Arduino, of Archimedes actually. So let's have a look. Archimedes. I'm pulling up these other tutorials. So, okay, so Archimedes, the AI robot owl, the original one had the it had a Google AIY Vision Kit, but it also had the motors running off of an Arduino Maker 1000, which was a Wi-Fi capable board, actually. So that was a little bit of overkill, but I probably just wanted to play with the Maker 1000, honestly. Any kind of small Arduino board or a Teensy is going to be really nice for running motors off of. And I programmed the Teensy with Arduino code. So here, oh, we didn't have a Teensy in this one, actually. We had a Raspberry Pi 3 Model B, again, and a Matrix Labs Matrix voice board. But I think in the end, I ended up changing this one to run off of a Raspberry Pi and an Arduino again, just because it feels really comfortable for me. And there's something to be said for pushing yourself, pushing your limits. But I feel like there's so many components that go into building a companion bot. You have to make it comfortable. You have to make it all the different types of programming that you're doing. For example, in this case, I'm trying to incorporate this Ocarina AI thing. I'm working with new hardware. I'm working with this heating pad here. I'm working with the Companion Core for the first time, which is supposed to make my life easier, but we'll see. And there's you have to think about mechatronics. You have to think about the personality of the bot. You have to think about all this other stuff that you wanted to do, and just like how it's going to behave and how that affects the programming that you do. So, in my opinion, it's fine to just stick with what I know. And in that case, I'm going to use this board to break out a Teensy or an Arduino, program it with Arduino in the Arduino IDE. But often I'll add a Raspberry Pi or something and just program it in Python, usually, sometimes JavaScript, mostly Python. But let's go back to Edge Impulse because they actually help a lot with this programming part. So I'm also going to be using this. You can export, you can train your model, you can deploy the model, and they'll deploy your impulse, hit Arduino. It gives you an Arduino library that works with the data that you trained. Where's my water? Build the firmware. Oh, they've got it for the Nikla Vision now too. Oh, cool. Oh, maybe I'll put that in. Oh, I don't know. Okay, but let's just pretend that's for the Nano 33 BLE Sense. You could run it directly on your computer or your phone. You can select optimizations. You can hit build, and it'll make you a little Arduino library that you can use to interface with your board in the Arduino IDE. Is this still going? Yeah, okay, so it's not having the low current shutdown, which is not surprising because this battery or this heater takes up to 2 amps. I'm basically just testing this heater with the power bank and seeing how warm it gets. It's still at a very comfortable temperature, so this is not ever going to get dangerous, which makes sense because they designed it for use in e-textiles, smart wearables, automotives, and things like that. So very comfy. I might not put any fur over this because it's actually cool enough that I think it would not be felt very strongly through it. The other thing is that this goes up to 7.2 volts. 5 volts to 7.2 volts. And my assumption is that if I put more voltage through it, then it would heat up more. So that's cool to have that option. Still building our Ocarina code. Oh man, what if I put it on the Arduino? No, it's for another day. Today I want to solder stuff together. We're on a timeline because I want to finish this ideally by Halloween. If not by Halloween, I want to finish it by Supercon. Hackaday Supercon is coming up November 4th through 6th. I've got a bunch of cool friends who are presenting. I'm just going to go with this new robot and like some other fun stuff I've been developing and talk to people about my PCBs and stuff. It's going to be a great time. And so I really have to finish this. And I think that the Edge Impulse Ocarina part is a stretch goal. It's something I'm very excited to implement, but it's not necessary strictly. I want to get all this structural stuff done first. So let's just let that go build, and we're going to start soldering stuff together. Hackster Impact was a great summit. Thank you! Last week. Was it just last week? Oh my gosh. Was it though? Yeah. It was the 11th and 12th. Last Tuesday and Wednesday, we had our Impact Summit at Hackster, which was splendid. And we've got our video recordings that are going to come out soon. It was a 2-day virtual event for talking about using creating electronics that measure, monitor, and protect our Earth's air and water supply. We had a ton of amazing speakers, so stay tuned for that. Be sure to subscribe, by the way. Subscribe to the channel so you don't miss this stuff. I'm really excited about some of the people I got to interview, including my friend Chris Adams, who is an organizer for climate action.tech. And we had people from the UN. We had Sarah Maston from Project 15. We had, I think we had Tim Van Dam and Adam Benzian from Elephant Edge. I could be wrong, but we do overlap on a lot of events. We had wonderful panels. We had a bunch of demos from people at Nordic and Microsoft and stuff like that. It's amazing. So stay tuned for Impact Summit recordings. Thanks for mentioning that. But yeah, now let's get into the hacking again. I'm going to unplug this. I feel like I've learned what I came to learn. So that's 2 things done. We tested out our little grabby paw. I'm going to do it again because I love it. This is a little raccoon paw. If you missed that part, it's a little 3D printed raccoon paw in flexi filament. And then we're also going to solder this together. Okay, so the way this works is that you have your board. Doop. I wonder if the Nano 33 BLE Sense is any better at doing servos now. It used to be that, you know, when the Nikla came out, it had supposedly tutorials for working with servos, but it didn't really work. In the OpenMV IDE, I tried it out. I couldn't figure out how to get servos to work based on the documentation, which is no shade. Like, you know, I'm really excited that those even work together. But I think that I don't have the experience to be able to work out on my own. I think there was an issue with figuring out which pins were which. But yeah. Anyway, using a separate board for servos is useful for that because you don't necessarily know how to use servos on your main board. This board is self-documenting. It says Companion Core designed for use with Teensy and Arduino Nano 33 BLE Sense. That's what I got here. Stick a mini breadboard in this box aligned with the breakout header rows. These guys. Solder male and female headers on as labeled. Male, 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 female, female. The reason that we're going to do that is because these 3 rows of male headers are breakouts for servos and neopixels and things like that, which generally have female headers. Connectors. Neopixels often come with male ones actually, but you can attach female ones to them. And these are female because we're going to make little wires run from the breadboard down to the Companion Core. I might actually not even solder headers there. I might just You can see in a previous iteration that I just attached them to the breadboard on one side and then soldered them directly into the header slots. This was before I had an extra row for those to go into, which honestly, now that I think about it, it's kind of... But there's another feature on here, which is that these are designed to connect pins across the board, so that if you want to use a pin that's on this side of the board, it's going to connect to one of these female headers. This board gets connected to these headers, and then if you want to break it out to a servo or a sensor or something on this side, you connect it with a jumper across here. You jump across these, and then just route it over there. It's connected to the row over there. And you just make sure that you're not shorting pins across the board. But also it just looks cool. So I'm going to start putting some headers actually on my... I plan to put them on this board, which turned out to be a Pi Pico W. And I think it'll still be interesting to play with that. But let's go ahead and do the headers on here. What I'd like is to get special headers that are specifically designed for this board. So imagine instead of a 2-row one, having a 3-row header that's exactly the length of this, and then the female ones being separate. But as is, I'm just going to go ahead and pick out some of my smaller pieces here and use those. Now that I think of it, I'm going to go hunt up an actual set of headers, because these are sort of my miscellaneous ones. Let me see if I can break up a big one. I'll be right back. Okay, so here's my big bag of headers. Oh, I've got the double tall ones as well. That's very cool. Oh. These are not the ones that I need, but these are really useful for if you want to make a board that's going to mount onto something, but also you still want to be able to use its pins and plug stuff into it from the top. Okay, let's just pretend with this Pico W. So say I want to plug this board into a breadboard, right? I would probably mount headers on the bottom. But what if I wanted to be able to plug stuff in directly to this board still and not plug it into a breadboard or whatever? I can use these. Mount them on from the top. This goes into the breadboard. This side goes into the breadboard, and this side gets stuff plugged into it. It's a very versatile type of header, and I love it. But I'm not going to use it right now. Instead, we're going to use regular female headers. Ooh, you know what? Oh yeah, I think I have enough here. Oh, maybe not. We might have to save the headers for another time. But let's put the male ones on just for fun. Oh, these are right angle. Guys! Nothing is ready for me to solder the headers onto here. So let's actually switch over to the edge impulse stuff and explore that for a minute. And I think we're going to wrap up soon because it's been 20 minutes and I don't want this to go too long. There's going to be lots more hacking in the next week or two as we lead up to Supercon. Yes, we will definitely send pictures and video and all kinds of other stuff, but it is too bad that we will not see you there. Let's check on our edge impulse model and see. Oh, there we go! Built Arduino Nano 33 BLE Sense firmware. Click on the script for your operating system to flash the binary. So basically they give you multiple different scripts here. And I will use the Mac one to flash it. And then from your terminal or command prompt run, edge impulse, run impulse. I think this has changed a little bit since the last time I did it, so I'm going to try. And it may not be as exciting for a minute because I don't have that window pulled up, but we shall see. Where's my cable? Yes. Computer, meet Arduino. So the way that you gather data for these things in the first place is I played my ocarina a bunch at the microcontroller. First, you have to load a script onto the microcontroller that tells it to listen for data from a specific input, in this case the microphone, but it could be the accelerometer, it could be light data, whatever. And then it's going to ferry it up through the USB cable, through your computer, and a daemon running on your computer to the Edge Impulse servers. And then on the server, you do all this stuff with arranging the data and training your model. And so you tell it, here there's like a little Arduino Nano that I pulled in data from. Oh my! Here's all the data I collected. We had do, re, mi, and fa, and then also noise. And we tested it. Ooh. Oh, maybe I didn't. Oh, maybe there was such a good match because I overfitted the data set. Can I just rebalance this? Oh no! I should have created testing data as well as training data. Well, that kind of explains the 100% results I got because that's a little implausible, honestly. Okay, can you rebalance it from straight in here? I think you can. Filter, select the what? Might not be able to rebalance it just like that. So what I should do, you can also like manually move stuff between the training and test set, but it would be a fair amount of training data, so I don't necessarily want to do that. Well, anyway, let's just see how it does. It hasn't been tested. We're gonna see how it goes. Okay, so I've downloaded this zip file and I'm going to unarchive it. I'm going to click on flash_mac.command. I'm getting a security alert in my Mac that says it cannot be opened because it's from an unidentified developer. That's not surprising. It says it cannot verify that this app is free from malware. Again, not surprising. That's something it does all the time. So I'm going to close that alert, go into my security settings in my preferences on my Mac. And it gives me a screen that says flash Mac command was blocked from use because it's not from an identified developer. So I'm going to hit this button that says open anyway. Once again, I get a pop-up that says it cannot verify the developer of flashmac.command. Are you sure you want to open it? You'll be overriding system security, which can expose your computer and personal information to malware. It's very Halloween. I'm going to hit open, despite the fact that the cancel button is highlighted. I've made that mistake before, and then it's a real pain to try and get it to run it again. Okay, so now let's take a look at the screen we're getting. I'm going to remove that screen share and do a new one so you can see what I'm doing. It's opened it automatically in the Mac's Terminal app, which isn't my fave. I usually use iTerm. But yeah, here you can see what happened. Finding Arduino Mbed core, finding Arduino Nano 3 BLE, 33 BLE, flashing the board. So I had this connected over USB, and it found the board. It erased the flash. It's now written the new firmware, and it's ready to go. So now I have to go per instructions into there. And what did it tell me to run? I think I took a screenshot. It's always good to take a screenshot when it's telling you to do something. It says, oh no, I didn't take a screenshot. Oh, I'm the worst person. I have to go back into the Edge Impulse environment and try to find where that is. But let's actually pull up the docs first. So Edge Impulse, Arduino Nano. Makes sense. Yes, it's here. Let's see. Terminal. Edge Impulse Daemon, not that one. There's definitely like Edge Impulse dash run dash something. I'm just gonna export the model, which is a little annoying because it'll take a while, as you saw before. If I were watching this video, I could just scroll back, but so it's gonna build the model. Maybe it'll be faster since it just did this. And we can all watch it in Firefox. Again, everybody, this is not the most glamorous show in the world this week. We are doing live hacks, which means that there will be thrills and spills, inevitably. Spooky notifications. Tariq, what other states says, do y'all hold events in, or are they just held in California? So, Supercon is actually not my event. It's held by Hackaday, who are super cool, and it's down in Pasadena, so that is in California. But, pardon me, there are lots of other really cool events that I recommend. So there's maker fairs everywhere, including New York Maker Fair. In other states, let's see, there's ones that I like include DEF CON, obviously, for hardware badges. That's really cool. But you have to be very security aware. I'm not going to give you any hard and fast rules, but, you know, also anyone else, feel free to chime in with what events you go to. What else? So yeah, DEF CON is held in Las Vegas, Nevada each year. There's Cascadia JS, which is held up in Washington. There's Tour Camp, which I've never actually been to, but it's also up in Washington. There's in previous years, there's been Crowd Supply Teardown, which happened in Portland. Very cool event run by our friends at Crowd Supply. Let's see. There's also tons of maker events in England and other countries. Like there was just Maker Faire Rome. There was one in France that I forget where it is. Maker Faire is very cool. On the more industrial side, there's lots of ones. Let's see. I mostly know about ones happening in California or in Europe. But RosCon was just happening. No, is it happening now? RosCon is a open robotics system, robot operating system from Open Robotics that's happening in Kyoto, which is very cool. There's only one or two in Ireland. Oh, what ones do you know of, though? Are they maker fairs? Anyway, that's super cool. Yeah, let's see. What else? There's definitely more industrial ones. TechCrunch Disrupt just happened here, and there was a whole section for hardware, so that was kind of cool. Yeah. I've been to Maker Faire Detroit, which is very cool. Also, Ann Arbor Maker Faire was my first Maker Faire back in 2009. Love that place. So lots in Michigan. Still building. I think that actually, since this takes a while, I'm going to come back with more another time, because watching that build is not the most fun thing in the world. I'm going to show you a little bit about how I put together this 3D printed flexible paw that I'm so obsessed with, and then maybe sign off for now. But we will be back soon with more Halloween goodness. As I mentioned, I'm just so excited about this little flexible paw that I built. I want to show you in case you want to also build prehensile 3D printed pieces for your robot. Very good for Halloween. And so, yeah, basically I took a model that I put together. First, I sketched out the paw here. I believe that's the first thing I did. Yes. Outlined it in a sketch. I'm using Onshape, which again is a browser-based CAD utility. So very parametric. I sort of sketched out on a piece of paper what sides I wanted things to be and sort of made a rough outline on here and then revised it so that it sort of all fit, because sometimes when you make the rough thing in here, it's tough to get it actually what you're actually trying to build aesthetically as well. There's a bounding box around here because one thing I often do is do an extrude to remove things around it. But it looks like I didn't actually use that this time. Interesting. So then we also, the second step that I did was building the side profile of the paw. You can see I made these trapezoids and sort of had fun like defining different shapes of things. This could be much cleaner, but it's not. But you can see where these different pieces are. This is sort of the profile I started out with, but those middle parts are obviously way too tall. They ended up way shorter. And when I show this, you can actually see where it would be at this stage in the programming, in the building of the paw. So when you stop selecting the sketch, it goes back to showing you the finished piece. But since this is early in the process, it'll show me the paw outline. Then I go ahead and it'll show me the first extrusion I did. Then it'll show me the side profile sketch. Then it'll show me where I cut away those extra parts. This is a place where you can see that there's this bounding box around it that I actually used as the profile for extrusion, removing the material that I didn't want. Again, here there's a spot for folding it around material so that it'll hold very securely to a surface. And then here's a little spot for the thread to go through. Just a little extrusion all the way through there. So what did we do next? We made another sketch. What's that? In the face. Oh yeah, making the little thingies and toes. Extruded those out. Next up was another sketch. Where was that? Oh, here. That was to make the channel for the thread to go through. Then we extruded that out. We made the hole through everything. And then I ended up making a bunch of mounting holes so that I could easily connect it to other stuff. So let's see. We did another extrusion this way to cut out that channel. This channel just goes between the outer toes and through the middle ones. Actually, we've got kind of a slice cut out here. Oh, I see. So then I did more refining of the contour of the toes. Cutting stuff out, putting stuff in. Chamfering things. So making them all look nice and beveled. Some more extrusions. And then finally the extrusion through here so that I could connect a bar across it to give the fishing line a place to attach at the end of the paw so that I can pull against it and wind up the whole thing. So again, this is linked both in the description below and in the project, which I've shared on Hackster, where you'll be able to continue to see updates on this. I'm really excited to now go and look at this LOOMIA backlit user interface. Ordering that is going to be a game changer. It will slow me down to wait for that, but I think it'll be a perfect little raccoon face for a robot. Ah! Okay, thank you so much for joining me on this little entry into Halloween. And also companion bots, which are one of my favorite things, as you probably know if you've ever met me or seen me on the internet. I'm very excited for my other ones, Fenrir and Archimedes, to have a new friend. and it's going to keep me warm and comforted through the cold winter months when I'm not allowed to have a pet. So I'm just going to build them. Thanks again for joining me. As always, hack on. Be sure to subscribe if you like this kind of thing and want to see more of where these robots go. Also, interviews with lots of cool people in hardware who are not me. But I asked them a bunch of questions about cool stuff they're doing. And also to see all those videos that are coming up from the Impact Summit. All kinds of cool stuff about protecting our environment with electronics. Thanks again for joining. We will see you soon. All right, bye. Have a great week.